Distinguished viewers all over the world, welcome once again to Simplified Maths class. I am your host, Mr. Mike Omeni, and today we bring you the topic polynomials. Alright, and what is a polynomial? A polynomial is the sum of separate terms of variables with positive powers and with a constant term. And this constant term can also be zero as well. That's what a polynomial is all about. And then we have an illustration on the board. They say given the cubic polynomial 7x3 minus 8x squared plus 6x minus 10. Please understand that the variable in this polynomial is x. The variable is x. But since the highest power of the variable is 3, the highest power of the variable is 3. It means that the polynomial is a cubic polynomial, or a polynomial that is of the third degree. Please don't forget that. That's because the highest power is 3. And if you look at this polynomial 7x cubed minus 8x squared plus 6x minus 10, you will understand that there are also 4 terms of that polynomial. The first term is 7x cubed. The second term is minus 8x squared. The third term is 6x. And the fourth term, which is a constant, is minus 10. And we have said that sometimes the constant can be 0 as well. So this polynomial has 4 terms. The first, second, third, and the fourth term. And the polynomial is a cubic polynomial because the highest power is 3. That's why we call it the polynomial of the third degree. Alright, so let's take what we call degree of a polynomial. Degree of a polynomial. Alright, so I have explained what we call the degree of the polynomial. Let's say you can be asked to find the degree of the following polynomials. We want to find the degree of the following polynomials. Alright, the first polynomial could be 5x raised to power 4 minus 6x squared plus 7x plus 2. Okay, so we have 6x raised to power 5 minus 3x raised to power 4 plus 7x. Now the third one could be, let's say, 2x raised to power 3y squared plus 6x squared y, let's say minus 8x squared y plus 6. Now these are all polynomials. They said we should find the degree of the polynomial. Alright, and we understand that the degree of the polynomial is the highest power of the variable of that polynomial. So in this case, in the first one, solution, if you look at the first one, so we have 5x raised to power 4 minus 6x raised to power 2 plus 7x plus 2. Now this polynomial you're looking at is of which degree? The degree of the polynomial is of the fourth degree. The polynomial is of the fourth degree. Why? Because the highest power of the unknown, which is x, the highest power of the variable x is 4. Now understand that sometimes the polynomials can be arranged in ascending order of the powers and sometimes in descending order of the powers. Here it is in descending order of the powers, from the power 4 to power 2 to power 1 and so on. So it's in the descending descending order of the power. You can have another one this way. Maybe they just give you 5 minus x squared plus 6x cubed minus x raised to power, let's say 5 plus 2x7. Alright, so you can have it in that order. So you can see that here in this polynomial, the terms, that's the variables, are increasing. This is power 2, power 3, 5, and 7. Okay, so some polynomials are given in increasing order of the powers, while some are given in decreasing order of the powers. It doesn't matter. Any order it is given is still okay. Alright, so the polynomial here is of the 4th degree because the highest power of the variable is 4. Alright, so number 2, we have the second one, 6x raised to power 5 minus 3x raised to power 4 plus 7x. Now, if you look at this polynomial, you see that the polynomial is of the 5th degree because the highest power of the variable x is 5. So the polynomial is of the 5th degree. Is of the 5th degree. Please don't forget that. Alright, now let's check the third one. The next one we are given is 2x raised to power 3 y squared plus 6x squared y minus 8x squared, let's 8x squared y squared, 8x squared y squared, then plus 6. Now, before I forget, in the second one where we have said that the degree of the polynomial is 5. Why? Because the highest power of the variable is 5. So the polynomial is of the 5th degree. Don't forget that this particular polynomial has the constant term being 0. That's why in the definition of the polynomial, we told you that sometimes the constant term might be 0 or may be 0. So in this case, the constant term is 0. Alright? But if you look at this one, the constant term is 2. This one, the constant term is 6. This one, the constant term is 5. Okay? But this particular polynomial, the constant term is 0. Please understand that. Alright, so here we want to find the degree of this polynomial. Now, a polynomial that has 2 variables, if you want to find out the degree of that polynomial, you have to take the 2 variables and sum the powers. You have to sum the powers of the 2 variables. Alright, it therefore means that, don't forget, this is the first term of that polynomial. This is the second term of the polynomial. This is the third term of the polynomial. And this is the 4th term. Alright, don't forget that. Alright, so the highest power here of the variable is x3, y2. X raised to power 3, y raised to power 2. So in order to know the degree, you have to add the powers of the variable. So it therefore means that this polynomial, the polynomial is of degree 5. It's of the 5th degree, or it's of degree 5. Why? Because if you take this x raised to power 3, y raised to power 2, you simply add the powers. 3 plus 2 will give you 5. Now, but if you look here, this is x raised to power 2, y raised to power 1. Y alone is y raised to power 1. 2 plus 1 will give you 3. So it means this term has degree 3. This particular term. This term has degree 4. Because if you add x squared, if you have x squared, y squared, the powers 2 plus 2 will give you 4. So this term is of degree 4. Now the entire polynomial is of degree 5 because the highest power of the variable, which is xy, is 3 and 2, which if you add, you have 5. So that polynomial is of the 5th degree. Don't forget that. Alright, so we have the last one, number 4, and that last one is 5 minus x squared plus 6x raised to power 3, and then minus x raised to power 5 plus 2x raised to power 7. And if you look at this polynomial, you see that the polynomial is the type that has terms that are increasing in terms of the variable. The power of the variables are in the increasing magnitude. But what is the degree? The degree of this same polynomial will still be the highest power of the variable. And the highest power of the variable x is 7. So the polynomial is of the 7th degree. The polynomial is of degree 7. Or the polynomial is of the 7th degree, whichever one. So we've been able to know what the degree of a polynomial is. Without waste of time, we are going to be taking the additive inverse of a polynomial. The additive inverse of a polynomial. After knowing what the additive inverse of a polynomial is, we have to find out how to resolve the addition and subtraction of polynomials. Once we are done with addition and subtraction, then we can proceed to what we call multiplication and division, the long division, before we begin to take the factor and the remainder theorem. Alright, so let's proceed. We want to take the additive inverse. Additive inverse of a polynomial. Additive inverse. Alright, so if we want to find the additive inverse of a polynomial, it's simple. Okay, let's say find the additive inverse. The additive inverse of the polynomial P1 is equals to 2 plus 6x raised to the power 2 minus 7x cubed plus 4x raised to the power 5. And then we have P2, the polynomial is 8x raised to the power 5 minus 6x3 plus 2x minus 8. Alright, so we want to find the additive inverse of these polynomials. Number one, solution. So we have the first one. We're given that P1 is equals to 2 plus 6x squared minus 7x cubed plus 4x raised to the power 5. So the additive inverse of P, the additive inverse of P1 will simply be for you to introduce a negative sign before the polynomial. 2 plus 6x squared minus 7x cubed plus 4x raised to the power 5. So it simply means that each of the terms of that polynomial will be multiplied by minus 1. Or you are simply introducing a minus sign to affect every term of that polynomial. Therefore, the additive inverse of P1 will be equals to, this minus sign affects 2 to be minus 2. The minus sign affects this positive sign to be a minus 6x squared. This minus sign affects this minus to become positive 7x cubed. And then this minus affects this to be a negative 4x raised to the power 5. Please don't forget that. Don't just forget that, alright? Okay, it's okay. Don't forget that. So what we need to do is just to introduce a minus sign, and that minus sign would affect all the terms of that polynomial. So minus affects positive 2 to be minus 2. It affects positive 6x squared to be negative 6x squared. Minus affects this negative to become positive, and it affects this positive to become negative. So that's what we call the additive inverse of that polynomial. That was I1. Then the II, we have our P2 to be equals to, have 8x raised to the power 5 minus 6x raised to the power 3 plus 2x and then minus 8. Therefore, the additive inverse of P2 will be equals to, so we have a minus sign introduced before the polynomial. So we have 8x raised to the power 5 minus 6x raised to the power 3 plus 2x minus 8. So the additive inverse will be the minus affects this to be minus 8x raised to the power 5. Minus affects this to be positive 6x raised to the power 3. Minus affects positive to be negative 2x. And then minus affects this minus to be positive 8. So what we have just done is what we call the additive inverse of the polynomial. Alright, so without waste of time, after knowing what the additive inverse is, we want to know how we can resolve addition and subtraction of polynomials. So let's take the addition and subtraction of polynomials. Now don't forget, in addition of polynomials, you can actually take two polynomials and add them together. Sometimes the polynomial you want to add, you can be giving product at the same time before adding. Let me just give instances. So let's take addition and subtraction. Addition and subtraction of polynomials. So we want to see how we can resolve addition and subtraction of polynomials. Alright, so for instance, given P1, the polynomial P1 to be 2x raised to power 5 minus 8x cubed plus 3x minus 2. Alright, and then we have P2. And so we have P2 to be, let's say 3 or 7x raised to power 5 minus 4x raised to power 4 plus 2x raised to power 3 plus 10. Alright, so this is what we have. So we want to find, for instance, I find simply P1 plus P2. And then maybe we just want to find P2 minus P1. And then maybe we just want to find 3P1 plus 2P2. Okay, so we want to see how we can resolve addition and subtraction of polynomials. It's simple for any polynomial you are given. Alright, so look at this. The first one, we want to resolve solution. We want to resolve P1 plus P2. So we'll bring out our P1. Our P1 will be 2x raised to power 5 minus 8x raised to power 3 plus 3x minus 2. So we want to resolve this plus our P2. 7x raised to power 5 minus 4x raised to power 4 plus 2x raised to power 3 and then plus 10. Alright, so we simply have to take the terms that have the same powers to add them together. Say for instance you have x raised to power 5, x raised to power 5. So we are going to have 2x raised to power 5 added to this 7x raised to power 5. So we are done with the power raised to power 5. So let's take raised to power 4. There was no raised to power 4 here. There was none. There was none. So we are going to have, it means that x raised to power 4 missing here has a coefficient of 0x raised to power 4. It's missing. So it is 0x raised to power 4. But we have x raised to power 4 here. So this will be plus minus 4x raised to power 4. So this plus and this minus will still give us a minus here. Don't forget. Don't forget that. So we have 0x raised to power 4. We want to add a negative 4x raised to power 4. But plus minus is the minus we have here. So we are going to have 4x raised to power 4. Then after that we are taking 3. We have minus 8x raised to power 3 minus 8x raised to power 3 plus. Do we have raised to power 3 here? Yes. So we have plus 2x raised to power 3. Then after that we are going to take normal x. So we have plus 3x. Plus 3x. Okay, do we have squared? There was no squared. Please take note, we don't have power of x because we started with 5, followed by 4, followed by 3. But there is no square, there is no power x squared. That's why I have not brought it out. So after x squared, we have x, which is 3x. We have 3x here, 3x plus, remember that there is no other 3x the other way. There is no 2x, there is no 1x. That means there is no x raised to power 1 again. We only have one x raised to power 1. If we had another x raised to power 1 here, which is 7x, we would have added. But we don't have, so we can leave it that way. And then we can take minus 2. So we have our minus 2. And then minus 2, we have plus 10. So those are the two constants. The constant here is minus 2 and the constant here is 10. So we can simply add this. 2 plus 7 will give us 9. So this will be 9x raised to power 5. So we are adding the coefficients 2 and 7 while we retain the x raised to power 5. Now here 0 and minus 4. Alright, so even if you choose to ignore this, you still have minus 4. You can choose to ignore this, you still have minus 4. So what we have here is still minus 4. Minus 4x raised to power 4. It's like saying 0 minus 4 will still give us minus 4. So we have x raised to power 4. After x raised to power 4, we have x raised to power 3, x raised to power 3. So we consider these two. Minus 8 plus 2. Minus 8 plus 2 will give us minus 6. And both are for x raised to power 3. Alright, so but for x raised to power 2 we have. But we have 3x. So we have positive 3x. And then minus 2 plus 10 will give us a positive 8. So we've been able to add the polynomial P1 to P2. Addition is that simple. In addition, you have to select the terms that have the same power to add them. Corresponding terms with same powers must be added. Please, that's how the addition is done. Alright, so let's try the second one. II. They say we should attempt P2 minus P1. P2 minus P1. So what is our P2? Our P2 is 7x raised to power 5 minus 4x raised to power 4 plus 2x raised to power 3 plus 10. That's our P2. So they say minus, what's our P1? Our P1 is 2x raised to power 5 minus 8x raised to power 3 plus 3x and then minus 2. So we are taking P2. This is P2, which is this. We take it first, minus P1. This is P1. Okay, and don't forget please, this minus will affect every sign here. Take note of that. Alright, so we are simply taking the highest power, 7x raised to power 5. Alright, 7x raised to power 5. Do we have raised to power 5 here? Yes. So this will be minus 2x raised to power 5. So that will be minus 2x raised to power 5. So we are through with the raised to power 5. So here we have minus 4x raised to power 4. Minus 4x raised to power 4. Do we have raised to power 4 here? No. So we simply leave it that way. Then we take x raised to power 3. We have x raised to power 3 here, which is plus 2x raised to power 3. Do we have 2x raised to power 3 the other way? Yes. You can see this raised to power 3. So this will be minus, this minus becomes positive 8x raised to power 3. Don't forget that. We have 2x raised to power 3. This minus and this minus becomes plus 8x raised to power 3. So we are done with x raised to power 3. We take squared. There is no squared here. There is no squared. And there is no squared here. So it is discarded. After that we have normal x. Normal x. There is no x here, but we have normal x here. So we'll first take the negative sign and bring it down. And then before positive 3x. So that will be a negative 3x. Don't forget, this minus will affect the positive sign to become negative 3x. So if it was negative here, this minus will affect this negative to become positive. But what we have here is positive, so minus affects positive to become negative 3x. After that, we can take the constant. The constant here is 10 plus 10. There is minus here. This minus will affect this minus to become plus 2. Don't forget that. This minus affects this minus. Minus times minus, it becomes plus. So we are through. We simply now have 7 minus 2 will give us 5. Then 5x raised to power 5. So we are subtracting only the coefficients. So we come to this point. We only have x4 as 1. So that will be minus 4x4. But we have x3 raised to power 3, 2. We have 2 of these. So 2 now plus 8 will give us 10. That will be plus 10x raised to power 3. We are done with that. And then we don't have squared. We only have x. So we have minus 3x. And then we can now have 10 plus 2, which is plus 12. So we've been able to subtract the two polynomials. To subtract the two polynomials. Don't forget that. If you look at subtraction of polynomials, is done by the additive inverse. So what we simply do is that whatever we have here, we are adding it to the additive inverse of the other one. That's what subtraction is. Because this sign will actually affect everything here from what we have done. So the additive inverse of this added to this is still what subtraction is all about. Please take note of that. Alright, so with this now, we are going to the last one, which is 3p1 plus 2p2. 3p1. So let's see how we can resolve 3p1 plus that. 3p1. Okay, where will I clean? Let me clean here. So we want to resolve 3p1 plus 2p2. I think that's what they say we should do. Alright, so 3p1 I plus 2p2 will simply be, let's take our 3p1, will be alright, so 3p1 plus 2p2. So we want to use 3 to times this. We want to multiply here by 3 and multiply here by 2. That's what we want to do. So 3 times 2 here will give us 6 x raised to power 5. The multiplication only affects the coefficients, not the powers. So 3 times 2 will give us 6x raised to power 5. 3 times minus 8, that will be minus 24 x raised to power 3. 3 times 3, that will give us positive 9x. And then 3 times minus 2 will give us minus 6. So we've been able to multiply 3 by this. By taking 3 to multiply each of these coefficients, we have done that, including the constant. So here we have 2p2. 2 times 7 will give us 14 x raised to power 5. 2 times minus 4 will give us minus 8 x raised to power 4. 2 times 2 will give us plus 4 x raised to power 3. And then 2 times 10 will give us 20. So we've been able to bring out 3p1 plus 2p2. So the whole of this is 3p1 and the whole of this is 2p2. We can now add as we do add. So we are going to have, watch me, even if I don't need to arrange them out, I can simply add directly. Meaning that this is x raised to power 5 and this is x raised to power 5. So I'm adding 6 to 14. 6 plus 14 will give me 20 x raised to power 5. So I'm done with raised to power 5. Let me take raised to power 4. Raised to power 4. So we don't have raised to power 4 here, but we have it here. So that will simply mean I bring down minus 8 x raised to power 4. I'm done with x raised to power 4. I need x raised to power 3. So there is x raised to power 3 here and x raised to power 3 here. So what I simply do is minus 24 added to 4. Minus 24 added to 4. Minus 24 plus 4 is minus 20. So I have minus 20x raised to power 3. So I've been able to add this to this because minus 24 plus 4 will give me minus 20. Then x3, that's what we have here. So we are done with x raised to power 3. We'll simply take the one of x raised to power 2. There is no x raised to power 2. After that, take the one of x. We have 9x. There is no other x here, so only 9x. So we bring down the 9x. After that, we take the constant, which is minus 6. We add to 20. Minus 6 plus 20 will give us 14. So far, we've been able to treat 3p1 plus 2p2 by first multiplying 3 by p1 and then multiplying 2 by p2 and then adding the corresponding result. So we've been able to do that. So far, we've been able to understand what polynomials is all about, to know the degree of a polynomial, to know the terms of a polynomial. If you look at this polynomial, you see that the terms are 1, 2, 3, 4, 5. There are 5 terms here. This is the first term, the second term, the third term, the fourth term, the fifth term. Don't forget the terms of the polynomial. And the term that does not have the variable x or y attached to it, that term is called the constant term. Please don't forget that. So we are done with all this, including addition and subtraction. When next we meet in our next slide, we'll be taking multiplication and division of polynomial. And don't forget, it is the division of the polynomial that brings us to what we call the remainder theorem and the factor theorem, which are very important as far as polynomials is all about. And so don't miss our part 2 and part 3 of these polynomials. The part 2 will be the multiplication and division, and the part 3 will be the use of the remainder and the factor theorem. Don't forget, you don't need to miss any of this slide by any reason whatsoever. And for you not to miss any of this slide, don't forget to simply hit the red subscribe button if you have not subscribed to our channel. And if you have any question, please don't forget to drop it down in the comment section. I will respond to your question. Maybe by the time we are done with the whole polynomials, I will set a problem and expect you to answer this problem in the comment section. And so see you in our next slide. I remain your host, Mr. Mike Omeni. Have a wonderful day. Cheers.